Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 70 of physics, and today we are going to discuss the second method of heat transfer. In the previous lecture, we dealt with the conduction, and in conduction, heat is transferred from hot end to the cold end without the transfer of medium. In the second case, the process of heat transfer that we will discuss is convection. This process involves the transfer of heat through a fluid, that is liquid or gas, by means of bulk movements of the fluid itself. Ladies and gentlemen, remember that convection can take place only in gases and in liquids. I wrote in green, convection is the transfer of thermal energy by means of currents. Now, this is a special word called currents. If we are giving it a look from the perspective of electricity, then current is the flow of electrons. Electrons are flowing from one place to another place, and when electrons are flowing, then we say that current is produced in the wire. Here the currents means that the medium particles, whether it is of air or of a liquid such as water, the molecules or atoms are going physically from one place to another place, so then we are calling it currents. So here currents means that the bulk of movement of fluids itself. Now let us revise again this definition. Convection is the transfer of thermal energy by means of currents in the material medium, liquid or gases. Because in the solids, the molecules or atoms are tightly bound with each other, so convection cannot take place in solids. Remember these words. Ladies and gentlemen, the following two experiments will illustrate convection in action in fluid. So let us do the first experiment, and the experimental arrangements are shown in the figure. The main purpose of this experiment is to show convection in water, that is liquid, because we said here that it is only can be observed in liquids and gases. So let us first observe it in gases, in liquid. For the experiments, we need a large round bottom flask. You can see this here in this figure, that it is a large round bottom flask. And then we need potassium permanganate crystals. You can see that it is shown here in the figure that potassium permanganate crystals are there. If you want to see it clearly that how potassium permanganate crystals are looking, then this is the picture for you people, and you can see that these are the potassium permanganate crystal, and it is inside that flask at the bottom. Another thing which we need is Bunsen burner. Along with that, we need water. So I am writing water here as well. And there is a need of tripod, which you can see here, and then a tripod stand, and then we need another thing, and that is iron stand. These are the uh, materials which we will need to perform this experiment. Now what we will do, there are two steps. The first step is saying that you have to do what? You have to place the you have to fill the flask. Fill the flask with water. With water. Carefully place some potassium permanganate and carefully place some potassium permanganate. You have to do this. In the first process, and then we have to provide the Bunsen burner. So the second step in this experiment is place a Bunsen burner with a small flame. With a small flame under the flask. Under the flask. And then we will observe the different things, and we will summarize it later. But before that, let us perform the second experiment, and that is experiment number 2. First experiment was dealing with the convection in liquid. The second one is dealing the convection in air, that is in gases. The apparatus we need for this experiment is large box with 2 chimneys. This is a box. Remember that this is the box. This is chimney number 1 and this is chimney number 2. So we need these 2 chimneys in a box, and that box will be of the glass. And those chimneys are on the top of the glass. There must be a smoldering paper as well, that paper which is producing the smoke. So here you can see that there is a smoldering or smoking paper. Now what we will do is to perform this experiment. There are two steps inside this as well. Number one step is saying place the candle, place the candle below one of the chimney, below one of the chimney, which is here. If you are observing, that is a candle. Let me show it with a different color, so then you will see it that there is a candle, and beneath it it is written clearly lighted candle. So place the candle below the chimneys, light the candle, and then you have to light the candle. Remember this. In the second step, you will do what? Introduce smoke into the other chimney. Introduce smoke to the other chimney. Yes, and you can see that in here that you are producing the smoke inside this chimney by burning the paper. And place and place it over the other chimney. Ladies and gentlemen, and then observe the movement of smoke and observe the movement of smoke. Now these two experiments are enough to see the effects of convection. In these two experiments, we observed in the first case that purple stream of water are seen to rise vertically. You can see here that in this case they are doing what? In this case the stream of water is seen to rise vertically upward in the center of the flask of liquid and then sink again along the sides of the flask. So you can see that it is again then sinking. So you can observe that inside that flask. So, what does it mean? It means that the particles, the atoms, the molecules of the water are moving and they are spreading the purple color to all sides of the water, and after some time you will observe that the whole of water is now giving a purplish color. So it means that convection has taken place inside the large rounded bottom flask. In the second experiment, uh, the smoke will be observed to flow down from one chimney and up the other chimney. So it will start moving from here like this, and then this smoke will go to the other. So it means that the particles of air are transferring from one location to another location, which is also giving us the concept of convection. Now, ladies and gentlemen, let us observe the mechanism of the convection. Very important topic, and let us observe the mechanism of convection. The mechanism of convection. Ladies and gentlemen, the circulation of the purple streams of water in the first experiment or the flow of smoke in the second experiment represents a convection current. When the water at the bottom of the round bottomed flask or the air above the candle is heated, it expands. The fluid is now less dense than the surrounding fluid and therefore starts to rise. In doing so, the color region of fluid is the upper part of the flask. Being denser, now descend. The upper part of the flask become denser when you are providing heat to the bottom of the liquid in the flask. It means that the bonding between hydrogen and oxygen are broken, and as a result the water in that region becomes less denser, and when it is less denser it is moving upward to the top of the flask, making the upper region of the flask as denser one. When that part becomes denser, then it is again moving downward toward the bottom of the flask. This is shown by the arrows in both figures. In both the experiment, this movement of the fluid, that is water or air, due to a difference density in density sets up a convection current. I told you that at the bottom the density is less, at the top of the flask in the water, the density is higher. So, due to the differences between the two densities, the convection current is taking place. Ladies and gentlemen, let me tell you one thing, that is potassium permanganate solution is drinkable? No, absolutely not. If you are doing so, it may result in damage to the upper gastrointestinal tract, and as a result you have to do endoscopy to find the severity of the damage. So never ever try to drink any amount of potassium permanganate solution with the water. From the color is it is looking very attractive, and everybody want to drink some amount of that solution, but it is not drinkable. It is also damaging the adult respiratory system, and many other damages to the tissues are caused. So never ever try to drink this type of solution. Never try to drink this type of solution. Ladies and gentlemen, I have to write here a very important piece of information. Note it with yourself. A convection current is the movement uh, of fluid of fluid caused by the change in densities. Yes, I told you that this bulk movement is due to the change in the densities in various parts of the fluids. In various parts of the fluid. Ladies and gentlemen, what is fluid? Is there any difference between liquid and fluid? Remember that fluid can be liquid, the combination of liquids and gases. Both are combinedly called fluid. These two are flowing. So that is why, and liquid is different. Liquid is only liquid, no gas is involved inside the liquid. So here I use a word fluid, so it was necessary to clear the concept of fluid. Here the fluid means both liquids and gases. In the first experiment we observed fluid, liquid, which was water, and in the second experiment we observed the convection current through air particles. Combinedly these two are given a name fluid. So various parts of the fluid doesn't mean only in water. Ladies and gentlemen, convection current occur only in fluids, that is liquid or gases, but not in solid. This is because convection involves the bulk movement of the fluids which carry heat with them. For solid, the heat is transferred from one molecule to another without any flow of the molecules themselves. Ladies and gentlemen, let us quickly touch on the concept of conduction and convection. Both processes are used for the transferring of heat energy, or you can say internal energy, from one place to another place. But there is a main difference between the two. In case of conduction, the medium is not flowing. No flow of medium particles. It means that the particles are at their original position, only vibrating about its mean position. When we are giving heat and we want those particles to transfer it to the other part of the substance, then that heat increase the kinetic energy of the particles, and as a result those particles are moving vigorously and jolting the neighboring atom to take this energy and transfer it to the other part. The neighboring particle also jolting the next particle, and in similar way the energy is transferring from one part to the other part, but the medium particles are not moving from its original place. Ladies and gentlemen, if you have observed the movement of tanks in war, there is a belt. That belt is moving, and the wheels on that belt is not, they are on its place rolling, and they are moving that belt, and as a result the tank is moving forward. Exactly, the wheels, as the wheels are not moving from its place in the tank, at its place they are rolling over. Similarly, in conduction, the material particle, the medium particles are not moving, but they are transferring energy from one location to another location without any movement of the medium. But in case of convection, the similarity between the two is that both are used to transfer the energy. But in convection, movement of medium particles can be observed. Yes, similarity is that both are transferring heat, but in conduction, the medium particles is not moving itself from one place to another place to carry the heat energy. But in case of convection, yes, we saw that in the case of water, that potassium permanganate crystals are giving purplish color, and that purplish color is spreading all over the water. So it means that the particles are moving from one place to another place. Ladies and gentlemen, more about the convection will be in the subsequent lectures. Wait for that. With that, we came to the end of the convection topic. Tomorrow, we will discuss the very important radiation topic. What will happen in that, whether medium is required for that or not, we will learn that tomorrow. So be with me for the next lecture. Thank you very much for watching. Allah Hafiz.